Welcome to this webinar about working within contaminated land in the construction industry. So just a quick introduction to myself. So my name is Thomas Martin. I'm a land quality consultant for MCL Consulting. My specialist areas are brownfield site risk assessments, environmental monitoring, landfill monitoring, construction and environmental management plans, piling risk assessments, remedial verification, and waste classification. A few nice pictures of myself in action there. And so just an introduction then to MCL Consulting. So we're an environmental consultancy established in Belfast in 2007. We consist of 15 staff of scientists, civil engineers, ecologists, noise consultants, and support staff. So our work is mainly driven by the planning system. Work comes from working within the overall project management team to deliver schemes for their clients. So for example, architects, planning consultants approach us for work, and we deliver this work in individual disciplines. For example, just a standalone contaminated land risk assessment, or a noise impact assessment, or a flood risk assessment, or we can do it all together as one. We also manage our own client schemes throughout the planning process. So we can act as designer, planning, and environmental consultants. Our main focus then is to achieve planning approval. However, these tend to be within the waste sector, so landfill, recycling, and quarries. We also work within waste licensing and permitting, and resource exploitation and engineering control. So for example, groundwater supplies. And then we have a range of 13 main disciplines. So contaminated land, waste management, hydrogeology, hydrology, air quality, noise impact, odor impact, ecology, flood risk and drainage, plan consultancy, drilling, geotechnical, and topographical. So just the relevance of contaminated land issues to the construction sector. So during the planning process, MCL Consulting work with various disciplines to achieve planning permission for clients. And brownfield sites then may come with certain planning conditions attached, which require the expertise of environmental consultants, and we can provide this expertise on discharging these planning conditions. So when would you need a contaminated land assessment? So first off, brownfield sites, they're a potential human health and or environmental risk. So a contaminated land assessment is required if a site is currently in brownfield land, i.e. previously developed, or is within proximity to potentially contaminated land. And there's a few examples there below of brownfield sites. So garages, filling stations, gasworks, landfills, historical landfill sites, brickworks, manufacturing works, railway land, former and current railway land. This is just some guidance and legislation that we're obliged to follow. The list isn't exhaustive, but it's just a few that we follow. So the main one there is at the top, the land contamination risk management, known as LCRM. And I'll just go through that there briefly here now. So the LCRM stages, essentially there's 3 stages. So stage 1 is your risk assessment, stage 2 options appraisal. Now, both of the above are undertaken prior to planning permissions granted. And then your stage 3 is remediation and verification. So this can be required to be undertaken during and after development works. So firstly, so the stage 1 risk assessment. So basically, as I said before, it's undertaken prior to planning permissions granted. It's required if the site is brownfield land or within proximity to potentially contaminated land. And it essentially develops a conceptual site model, which provides an overview of complete pollutant linkages. Now, a pollutant linkage is basically a full linkage between source, pathway, and receptor. So your source could be a contaminant or pollutant, for example, hydrocarbons in soils. A pathway can be the route by which your receptor could be affected, for example, inhalation, thermal contact of the soils, or a receptor. So that's something that could be adversely affected by contaminant or pollutant. So for example, human contact with the hydrocarbons in the soil is a complete pollutant linkage. And the first stage is your preliminary risk assessment. So this is a desk study exercise, including the following below, consisting of a site walkover, review of historical and current ordnance survey maps, review of geological and hydrogeological maps, understanding of environmental setting of site, identifying types of contaminants likely to be present, and then ultimately it develops an initial conceptual site model describing any full pollutant linkages. And then your preliminary risk assessment concludes either that no further assessment is required and the site is suitable for use. So unlikely, and sorry, in this case, it's unlikely the planning conditions regarding contaminated land would be attached, and therefore the construction can begin. Or further assessment is required, including site investigation and further monitoring to address uncertainties and complete the risk assessment. However, if the preliminary risk assessment finds that there are risks, unacceptable risks, then a generic quantitative risk assessment is required. So this would entail further investigation. So a ground investigation consisting of boreholes and/or trial pits, collection of soil samples, groundwater samples, and ground gas data. The collected results are then screened against relevant generic assessment criteria. However, just a point to note that a generic quantitative risk assessment, it's only acceptable to use if generic assessment criteria can be used. If not, then a more detailed quantitative risk assessment would be required. And the generic quantitative risk assessment then concludes either that no further assessment is required and the site is suitable for use, or, as I said, a detailed quantitative risk assessment is required for a more in-depth assessment. Or unacceptable risks still exist and therefore remediation is required to ensure that the site is suitable for use. And then this is just a summary of the more detailed quantitative risk assessment. So this would involve defining the objectives for this tier of risk assessment, perhaps may include a more detailed or supplementary investigation, confirm which linkages need to be assessed, identifying or developing tools and criteria such as site-specific assessment criteria, assessing the risk and update the conceptual site model, decide what further action is needed, and then finally producing a report. However, one thing to note is regardless of what the GQRA finds, we always have to implement this sentence or two here, which basically sums up that even if the GQRA was defined that the site was clean and there's no contamination, should the construction works then begin and find that there's potentially contaminated soils, for example, then the works must stop and NIA, environmental health, must be notified, and environmental consultants should be taken or should be asked to come out to site and assess any potential risks. Then the stage 2 of the LCRM process is the options appraisal. So this requires identifying feasible remediation options, doing a detailed evaluation of options, and then selecting the final remediation option. So for example, contaminated soils could be bioremediated or dig and dump, or you could use a combined approaches on bigger sites, just in various different sections of the site. Then the remediation stage. So this is when the contaminated land risk assessment process becomes more relevant to the construction sector. This can be undertaken before and or after the construction phase. And just below there's a possible works required by construction sector. So excavation and disposal of contaminated soils, working with asbestos containing materials, dewatering of contaminated groundwater, emplacement of clean capping cover system over soft landscaped areas, site setup, for example, emplacing silt fencing to ensure no sediment runoff to a nearby watercourse, and construction of ground gas protection measures in new structures. And then after the remediation has occurred, the verification is the next step. And this is where environmental consultants would come out to site and verify that all remediation requirements were appropriately undertaken. And this can involve the likes of documentation of waste transfer notes to ensure duty of care for removal of contaminated soils, site visits to verify clean capping layers, and verifying the installation of gas protection measures. So there may be that some planning conditions are attached to, after the PRA and the GQRA risk assessment has been undertaken, there may be some planning conditions attached by Environmental Health or NIEA, which is relevant then to the construction stage. So these could be the remediation that I previously mentioned, such as removal of contaminated soils, construction and environmental management plans, groundwater and surface water management plans, piling risk assessments, and the verification stage, just basically verifying that all remedial measures were appropriately dealt with. And then the contractors are usually charged with remediating and verifying the works. So for contaminated soils, for example, this may require delineation of hotspot areas required to be excavated. So for example, hydrocarbons may have been detected in various areas of the site, but not everywhere. Therefore, only certain high-risk areas need to be excavated. The contractors will be in charge of appropriate removal and disposal of contaminated materials, and perhaps the design of ground gas protection measures into the building design, which are ultimately to be constructed by the contractor. Soil capping verification is another works required. So sites with contaminated soils usually require at least 600 mil of clean capping layer over soft landscaped areas, or to the depth of buried surfaces, which I'll talk about in the next slide. So the following process is usually required to be undertaken by the contractor. Reduce the area to 600 mil below formation level. The installation of a visual marker permeable membrane, for example, orange mess fencing across the area, and then the emplacement of the 600 mil. So it's usually in the order of 100 mil of crushed stone capillary layer, 300 mil of clean imported clay subsoil, and 200 mil of topsoil. And then this has to be verified either by pre and post survey data and or just hand digging to physically measure the total depth, as can be seen in the picture there. And then regarding the protection of services, so buried services may be required through contaminated soils. Therefore, a clean cover system should be implemented to the full depth of the services. And then this eliminates the risk to future ground workers who maintain the services, and also protects the services themselves from being in contact with the contaminated material. Another planning condition that may be attached then is a construction environmental management plan. So this can be required when there are risks to local environmental receptors from construction activities, for example, the risk to a nearby watercourse. This may require the installation of silt fencing to stop sediment flowing into the watercourse, or the installation of silt busters settlement tanks. Visual inspections of watercourses by site staff, like daily visual inspections, collection of surface water samples, liaising with NIA throughout the construction stage, putting together a site waste management plan, so specifying procedures for collection, storage, and disposal of all waste products, protection of ecological receptors, and adhering to pollution response and spill procedures. Another condition that may be attached is the groundwater and surface water management plan. So this could be required when building on a site which has contaminated groundwater. So it basically ensures that construction activities are not adversely affecting the underlying groundwater or allowing for the mobilization of contaminants towards nearby watercourses. So boreholes may be built on site to allow environmental consultants to collect groundwater samples. These will need to be protected throughout the construction stage. Access points kept for surface water sampling locations, liaising with environmental consultants for sampling dates and issuing reports to NIEA, and proposals for dealing with exceedances of parameters within groundwater or surface water, if any. Another condition attached to a planning application is the piling risk assessments. So this can be required when piling uncontaminated land due to risks such as below. So for example, the creation of preferential pathways through an aquitord or through a low permeability surface layer, direct contact from contaminated soil arising by site workers, direct contact of the piles or engineered structures with contaminated soil, and contamination of groundwater and subsequently surface waters by wet concrete, cement, paste, or grout. And essentially, the piling risk assessment is carried out to ensure the most appropriate piling method is used to mitigate against these risks. It may be that the method chosen is the client's preferred method, or the method may have to change based on what the piling risk assessment finds. And essentially, this is relevant to the stage as some piling methods create waste arising of contaminated soils, and these soils will then need to be stockpiled and for removal off-site. And like a site area will need to be set aside for the stockpiles, and waste management procedures will be required. The next topic we have here is waste classification. So regarding the analysis of waste classification, it's commonly assumed that WAC, waste acceptance criteria, is the only analysis required to determine which landfill type waste can be disposed to. There's been a lot of times we've been asked by clients to come out to site and ask for, or to take a WAC sample, and then we've basically had to explain that first of all we need to undertake WM3 analysis and then WAC analysis if required. So the second point there, it says waste classification consists of WM3 analysis and WAC analysis, and essentially WM3 analysis determines if waste is hazardous or non-hazardous. And if it's hazardous, waste must be disposed of at a landfill accepting hazardous waste. And that's essentially the end of the line for that sample that's taken. WAC analysis would not be needed for that. However, if WM3 analysis determines that waste is non-hazardous, then WAC testing can be undertaken to further determine if the waste is inert or non-hazardous. And just a side note there regarding asbestos, which I'll be talking about later. If asbestos is found greater than 0.1%, then the sample is deemed hazardous, regardless of any other testing. So from a financial perspective, the best approach to waste classification would be to collect samples for WM3 analysis first, as there's no need for WAC analysis if WM3 analysis returns samples as hazardous. However, in practice, mainly because of time constraints, samples are analysed for WAC and WM3 at the same time. To save time, essentially this would mean that the likes of ourselves will only come out once to sample, and then one report will be needed, which saves on time. Whereas if we were to test separately for WAC and WM3, then there would be 2 site visits and 2 reports essentially. Regarding the waste classification sampling, so samples can be collected in situ prior to excavation works. So ones could be mapped out determining inert, non-hazardous and/or hazardous waste zones for removal. But samples could also be collected from stockpiles on site. A plastic membrane should be placed below and above stockpiles to prevent contamination of underlying soils, as in that picture there. I'll just take you back to the previous slide there, that there's possibly bad practice of stockpiling, and I'm assuming that's, you see that on most sites, but there's no membrane on that site, whereas you can see there on this slide, that's better practice for stockpiling. And then also different soil types should be stored in separate stockpiles, and the stockpiles could also be zoned out for inert, non-hazardous and hazardous wastes. And again, from a financial perspective, it is recommended that samples are collected in situ prior to excavation, as this reduces double loading, therefore saving time and money, as samples don't have to be excavated once for stockpiling and then excavated again for loading, saving on time and costs. However, in practice, this is not always possible. Therefore, planning ahead can be useful to save on time and costs. Another aspect of building on brownfields or contaminated sites is the importation of soil. So clean soil will need to perhaps replace contaminated soil that's been removed off-site. So topsoils or subsoils, regarding a greenfield soil declaration, topsoils, subsoils can be imported to the site under a greenfield soil declaration. Firstly, a notification needs to be made to the NIA prior to the movement to site. And under a greenfield soil declaration, NIA will therefore not regard this material as waste, and therefore waste management controls aren't applied. And for a greenfield soil declaration, both the source site and the destination site will require planning permission. However, even with what's considered green, clean soil, the material will still be required to be tested for human health screening, as greenfield soil may still contain naturally occurring elevated levels of contaminants. For example, nickel can be naturally occurring in a lot of soils throughout Northern Ireland. And then the testing, it's usually done one test sample per every 250 cube of imported material. I haven't said here on the slide, but it's also useful to note that testing should be taken at the site, at the source site, before emplacing material over the site that you're developing. Just in case if it didn't pass the human health screening, then it would need to be excavated again and more clean material brought in. So should always sample at source for best practice. And then soil from a brownfield site. So soils from another brownfield site or multiple sites could also be imported to the site you're working on. The destination site requires a waste management exemption. The source site is required to have planning permission. And the material is also required one test sample for every 250 meters of imported material. And must say that an exemption must be in place before soil movements are made, and this process usually takes a month. Another aspect of working within contaminated sites is dewatering requirements. Now, dewatering foundations may be required anyway for various reasons on sites with a shallow groundwater table. However, if the ground investigation during the GQRA stage found contaminated groundwater, then dewatering would be required as a means to protect the workers and the surrounding environment. Groundwater should be pumped, transported, and disposed in line with waste management licensing regulations and the water order. And the reasons for this is that hydrocarbons in groundwater can affect workers' health through inhalation of vapors, and measures are required to prevent uncontrolled release of contaminated groundwater. And then on to asbestos. So asbestos it's a hugely significant risk on brownfield sites given the historical widespread use of the material. It's found within buildings and soils consisting of demolished buildings and waste left on site. It's considered a human health risk via inhalation if detected within soils. It's seen quite a lot written in places that it's commonly assumed there's a safe limit of less than 0.001% as a safe limit for human. However, there is no safe limit agreed, and therefore the detection of any asbestos is a human health risk. Essentially, asbestos is just any detection of asbestos is a red flag. And that's a photograph actually taken by myself recently there. There's asbestos fragments within the soils in that site, and just to highlight, you can also see just at the top of the photo, it looks like a nice green field site, and then once you start doing your ground investigation and taking trial pits, you soon to see that the site was basically riddled with asbestos. Therefore, that's just highlighting why your first stages that I talked about at the start are required before the construction stage occurs. And then managing asbestos. So if asbestos is found within the soils, it can be remediated through being covered with hard standing or capping of soft landscaped areas. This is to avoid the risks of human contact. Any excavations required should all be removed. So essentially, asbestos-containing materials should not be used for infill in other areas of the site. It's obviously all dependent on cut-fill calculations, but excavated material should never be used to infill in other areas of the site to bring levels up. But it's also acknowledged that it's costly to remove all asbestos-containing materials. So therefore, once final levels are achieved, these areas should be covered with clean imported material and/or hard standing, and this then acts as an engineered barrier to mitigating the risk of human contact with the asbestos in the soils. However, what I've mentioned about above is relevant to the protection of the on-site users. So, for example, residents out in their gardens once a residential development has been complete. However, construction workers are exposed during the excavation and demolition works to the dangers of asbestos. So, regarding managing asbestos within the construction stage, so only licensed asbestos contractors can remove high-risk, unbound asbestos. You must adhere to the control of asbestos regulations, and the CDM regulations require that you determine whether there's a risk that the work might disturb any asbestos materials, including any potentially unidentified, presumed, or hidden asbestos, just like the picture I talked about in a few slides previous there. And the removal of asbestos is required prior to the construction works beginning. Site areas should be marked out where asbestos was found, and during the removal period and perhaps throughout the entire excavation stage and construction stage, the following should be employed. Ambient air monitoring is required during the works to monitor asbestos in air concentrations, and full PPE should be provided to all workers. And the next topic is ground gas. Certain sites could have a risk of ground gas, especially brownfield sites, because the made ground can be a source of your ground gas, or even a nearby site itself. For example, an historic landfill, ground gas could migrate towards your site that you're working on. So basically, depending on the ground gas concentrations detected during the GQRA investigation, and depending on the building type as well, a certain amount of ground gas protection scores are required. So the next three slides are taken from the tables from the guidance that we use, BS 8485. And essentially, it describes the three methods in which gas protection points can be achieved. So this could be through your structural barrier, ventilation, or gas membrane, or a combination of all three. So there's certain points achieved for the gas protection scores for the structural barrier. For example, the second one there, the in situ ground bearing floor slab will give you 0.5 points. Then your table for your gas protection scores for the ventilation protection measures. For example, a passive subfloor dispersal layer can get you 2.5 points. And then the gas protection scores for gas resistant membranes could get you 2 points. So it may be that the building type that you're working on requires, for example, 2.5 gas protection points. So a gas membrane, for example, would get you 2. And then if we go back, say, for example, a structural barrier, so your ground bearing floor slab would get you 0.5 points, therefore achieving the required 2.5. And then ground gas verification. So this is relevant to the construction stage, as contractors may be installing these measures such as the floor slabs, ventilation voids, and gas-resistant membranes. So basically, to conclude there, so in a summary, basically working within contaminated land in the construction sector, prior to planning permission being granted, potentially contaminated sites need risk assessed. And to start off, your desk-based studies and your initial ground investigation help to achieve planning permission. And then once permission is gained, conditions may be attached which affect the construction stage. So that's your remediation and verification that I mentioned earlier. And therefore, contractors may be left with the responsibility of managing working within contaminated land, setting up the site for mitigation measures for protecting workers and local environmental receptors, installing protective measures for end site users, and then liaising with the environmental consultants through this process. And then you would require the verification and remedial measures resulting in a suitable for use site. So ultimately, working within the contaminated land, it's a rewarding process where you can see contaminated brownfield, unsuitable land transformed into a modern, suitable for use land. So thank you for listening. I hope that was useful, and if you have any questions, feel free to ask.
Yeah, thank you, Thomas. And yes, if anyone does have any questions, please do feel free to use the chat there. A lot to be mindful of, and a lot of very insightful points indeed. We do have one that's come through already. Thomas, if you don't mind, I'll ask it now.
Yeah.
The presentation talked about carrying out WM3 and WAC testing on soils for disposal. Can you elaborate on what WM3 analysis is and why is it required along with WAC testing?
Yeah, so basically, yeah, like we get, I think I said before about how we get a lot of clients that would ask just to come out to site and sample for WAC analysis, and then we have to describe that it's essentially useless unless you've got your WM3 analysis first. So your WM3 is a chemical analysis that tests the hazardous properties of the soil, so to see if it's explosive or flammable or carcinogenic. And essentially then if it's deemed hazardous, it's just that's it, it's the WAC test and there's no need for it. However, if it's deemed non-hazardous, then WAC testing is the testing that's carried out to see how the soil essentially behaves in the landfill site. So it's a combination of a solid analysis, within the lab, which determines, for example, how organic the material is, and tests for some key contaminants. And also it's also a leachate analysis to see if the soil would leach out and what would be the cause if it was to leach out of a landfill. So essentially your WAC analysis can determine if a non-hazardous sample is either non-hazardous or inert, so it can go to perhaps an inert facility, which again is which is cheaper to dispose of too, so it has a financial impact there as well.
Okay, thank you, Thomas. Thanks for that. We have another question here. Just on the gas monitoring, what's the difference between CS3 category and CS2 category? If an SI raises that areas of the site are CS1 with other potential areas as CS2. I can read that again if you like.
Yeah, sorry. Please.
Would you like me to give really low?
Yeah, please.
Just on the gas monitoring, what's the difference between CS3 category and CS2 category? If an SI raises that areas of the site are CS1 with other potential areas as CS2.
So usually in a case like that, we would take the higher risk just as a precaution. So
right, I'll just interrupt you there, Thomas. There's things through another week. Just add on to that question.
Yeah.
Get finished. There's the second question. To avoid further gas. So I'll start from the top on this one because there's a wee bit added on here at the end. Yeah. Just on gas monitoring, what's the difference between CS3 category and CS2 category? If an SI raises that areas of the site are CS1 with other potential areas as CS2, to avoid further gas monitoring due to time constraints, would you go with the worst category of the two?
Yeah, essentially, we would go for the worst category. It's just basically in order to play it safe. We would usually go for whatever the worst case scenario is. You could do, if you've got time, a lot of these investigations I know are there's not much, it's all about as quick as we can get them done, but you could do further analysis over a longer period of time if you had time, which we usually don't. But it's useful to ensure that gas monitoring is undertaken during periods of low atmospheric pressure and high atmospheric pressure as well. So you may find that the time when the assessments were carried out may have been carried out whenever least, or either worst case data or atmospheric conditions which gave the worst case data were given. But if we had to work on the data that we were given just for the monitoring period that we undertook, you would go for the worst case data, which would be your CS3 then.
Okay. Thank you, Thomas. Thanks for that. There's no other questions have come through yet, so if everyone's content, I think we can draw to a close there. And just to say thank you to CEF Commercial Partners MCL Consulting for this, and thank you to Thomas, and thanks for everyone for attending today. Thank you.
Thanks, guys. Thanks.
Well, that's nice.
Thank
Bye-bye.
you. Thanks.